Let's do a write-up for a 95% confidence interval on slope. Recall that slope is rate of change, so we're going to construct a 95% confidence interval on the increase in revenue spent by a customer on food and merchandise based on the admission fee to an amusement park. Recall we took one random sample of 51 customers and got the following regression line. The sample slope was 0.76. The interpretation is that for each additional dollar increase in admission price, the predicted revenue from food and merchandise increases by 76 cents. The assumption is that a park's admission price is reasonable given the market, and therefore the more prestigious the park, the more money people are going to spend. But this 76 cents is a sample statistic estimate of beta, the true slope or predicted revenue increase per additional dollar admission. We want an interval estimate of what the true rate would equal. We're going to follow the typical steps for a confidence interval write-up. For us to trust our line, slope, and interval estimate, we have three important conditions that must be met: linearity of the data, consistency of variance, and normality of the residuals, which conveys an independent random nature of the data. Random behavior tends to follow a normal distribution. We do not need the data to come from a random sample if, for example, we're following the value of something over time. We just need the fluctuation about the LSR line to appear normal, to behave in a random fashion. Residual analysis and/or looking at a scatter plot help us to verify that the three conditions or assumptions are met. On some problems without the data, a statement will usually be made stating that an examination of the data showed no concerns of violating the assumptions. Because of time involved calculating the standard error of the slopes, it's usually going to be provided. In fact, a computer printout will typically be shown. We did not know earlier in the course what SE, t-ratio, and p-value meant, but we have a pretty good idea presently. We will do a hypothesis test soon, but for now we want to use the information provided by the printout to construct our interval. And here is residual plot of the data. In the write-up, identify the interval and the parameter. These are t-intervals due to using standard error and not knowing the true standard deviation of slopes. Conditions are addressed by stating there is no noticeable pattern in the residual plot, so no concern regarding linearity, consistency of variance, or normality of the points about the line. We lose 2 degrees of freedom estimating slope because slope involves two variables. The critical t-score can be found on the calculator or simply by rounding to 50 degrees of freedom and using the t-table. And then we substitute the appropriate values into the confidence interval formula and display the interval. The interpretation of the interval is where one either displays solid understanding or leaves doubt in the minds of the AP reader. You want to understand what a slope is and what the interval implies in context. We should state that we're 95% confident that for each additional dollar increase in the amusement park ticket cost, the revenue spent by a customer on food and merchandise is predicted to increase somewhere from 66 cents to 86 cents. In cases where an interval is from a negative slope to a positive slope, we need to accurately describe what's implied. For example, if our interval had been negative 0.10 to 0.28, we would say that we are 95% confident that for each $1 increase in admission price, the predicted revenue would change somewhere from decreasing by 10 cents to increasing by 28 cents. A decrease would not be good. Our ticket prices may be getting so high that people are saving money on food costs by chewing on the waiting line ropes and drinking the pool water. That ain't good. Come on, you guys.